All right, time to do another lab. So let's do some soil testing and figure out what our soil texture is and what our percent silt, percent clay, percent sand is. Now, I'm in a place where there's several different soil types, so I'm gonna have to go out into the bush a little bit and dig myself a hole. And when you do this lab, I highly suggest you go to a park or open sort of area, abandoned lot, or Castle Hills, or not Castle Hill, Arbor Hills or something like that, where you can dig a little small hole and it's not going to bother anything. Probably shouldn't do this in your backyard. What you're going to need: a marker, just a simple ruler, a little bit of water, excuse me, maybe some allergy medicine, and this is an empty peanut butter jar. It's just a regular Jif peanut butter jar that I cleaned everything out of. And that's it. It could be any kind of jar, honestly. Just a jar that you can get the dirt into. As I've put a bunch of the soil, I dug a bunch of soil up, and shovel went all the way in, and I took like a handful from the top of the soil, which had a layer of organic matter in it, like these dead leaves and sticks and this sort of thing. And they were all floating, and you can see them floating in the jar now, actually. And then a handful from the middle of the soil, and then a handful from about 8 inches down. And I put them all in here. And then I filled it with water, and I shook the bejesus out of it, just like this, to break up all those soil aggregates. Now, we're gonna let this sit for about an hour. And you can already see, let me use my marker as a pointer here. You can already see the heavier sand particles already settling out. Remember, because sand is the largest particle, so it's going to settle out first because of gravity. Then we're going to have a percent silt, a percent clay, and then a representation of organic matter that's going to float. And you can see it already floating up here. So we need to let this little mixture sit on the tailgate here for at least an hour, and then we'll take a look. Remember, because the clay is going to take forever to settle out. Okay, the sand is already settling out now, and then silt will take within an hour. The silt should be settled out. The clay is going to take a little bit longer, so we need to let this sit for at least an hour, and then we can see our true soil profile right here on the tailgate of the truck with just a peanut butter jar. All right, students, here we are back. Now this is settled out a good bit. I should probably let it sit a little bit longer, but got stuff to do today. So here's what we need the ruler and the marker for. Our total is about looks like just over 3 1/4 inches. Okay, 3 1/4 inches. So we're going to make a note somewhere of 3 1/4, or 3 inches and a quarter is what we're looking at there. So 3 inches and 1/4. All right, and it looks like our sand layer is going to end at about 1 inch and just over a quarter. So say we can call that's an average, so we'll call that, because it's a little shallower on the other side, so we'll just for ease we'll call it 1 1/4. Our silt layer is right here. That is the silt right there. So that is only about just over 1/4 of an inch thick. Now if we move it around, it's yeah, almost 1/2 inch, right between 1/2 inch and 1/4 inch. So that would be whatever, 3/8. So approximately 3/8 of an inch, and the rest of that is sand. So we could just subtract it out, which is what we're going to do. So I've got 1 1/4. So I've got a 3 1/4 inch total, right? And then 1 1/4 inch of that is sand. 3/8 inch of that is silt, and then the rest of that is clay. Okay, and so we can just put that in and make it a percentage, and we can see our percent sand, percent silt, and percent clay. And then we also get to see how much organic matter we have. So we know that on the surface of the soil, we've got approximately 1/4 of an inch of organic matter, 1/4 to 1/2 an inch of organic matter everywhere out here over this soil. There's a layer of organic matter sitting on top of that soil, which is important. That is what decomposes to fertilize, to give nutrients back to our plants. Okay, in this soil here, there's a few things that we know just by looking at it already, even without calculating the percentages, and we'll get to that. Sand is highly erodible, so we know that close to half of this soil out here is sand. And then there's very little silt. Okay, silt is our best soil that we want. And then the rest of it is clay, which is highly compactable, and because the particles are so small, it causes serious turbidity problems in water, which is what you're seeing up here. This is tiny clay particles that are still suspended. Okay, so we know that it's erodible and can cause turbidity. Also, clay is compactable, right? So we can have soil compaction issues. So what this tells us is this soil needs to be left alone. It needs to have plants on it at all times. We can't really be clear cutting or doing a ton of mowing or anything, or spraying, herbicides out here and killing the plants. We need plants out here all the time, and we really shouldn't be driving vehicles over it or plowing it, because it will cause compaction, and if we plow it, then it's all going to run off into the water. So this is a wildland out here that we know just by looking at this peanut butter jar. And we took a shovel, a marker, a ruler, and an hour, and we can tell this wildland needs to stay wild. It needs to be left alone. All right, time to walk you through a little bit of the math. It's really not that bad. It's going to look scary when you see the board, but just you wait. I'll walk you through it. Okay, so if you remember back to our lab, the first thing we measured was the sand, which was about 1 1/4 inch. Okay, remember, these are approximations because we used a peanut butter jar on the back of a truck. So this is not super accurate or precise. In reality, we would use a large graduated cylinder in a lab and make sure that it's perfect. But this is a simple peanut butter jar lab. Okay, so the first thing we measured was about 1 1/4 inch. Now, if you just use a simple converter online, use onlineconversions.com, something like that, you get about 31 3/4 millimeters. Our middle layer, the next layer we measured, was about 3/8 of an inch, approximately 9.5 millimeters. And all I did was subtract those two from the total, which was our first measurement that we took, was 3 1/4 inches or so, which is about 82.5 millimeters. So I subtracted those two and I got the remainder of 41 1/4 millimeters. So these are, you do everything in millimeters. Millimeters just make so much more sense. Everything should be metric, but what I had was an inch ruler, so we did a little bit of converting. Okay, for break, phone died. Okay, so our remainder was 41 1/4. So when you do the math, you do it like this. You take the part divided by the whole times 100. So for my part sand was 31 3/4 divided by 82.5 times 100 gives you approximately 38.5%. And if we repeat that procedure, part divided by the whole times 100, you get about 11.5% silt. And then here, 41 1/4 divided by 82.5 times 100 is going to give you about 50% clay. Now, all this adds up to about 100%. In reality, a lot of times when you do this in the field, you might get 99, 98, 105, something like that, because of rounding error. Remember, these are all approximations because the truck wasn't totally level, and the peanut butter jar isn't totally straight, things like that. So there's some error in it. But like I said, this is a rough guess in the field. This is not the most accurate or precise way to do it. It's a quick way to do it in the field and tell the landowner. Anyway, you get about 100%. Now, if we were to do this for accuracy and precision, we'd use a graduated cylinder, and that would be much more precise. And if we wanted to be more accurate, we would take a whole lot more samples than just one. And we would spread those samples out across the property evenly, and then we would be both accurate and precise. Now, if you use the soil texture pyramid or triangle, and I think there's should be another video on how to use those, but if you use that correctly, what you get is right at clay or right on the edge of a sandy clay. That's what our soil texture is by definition. And then once you have that, you can start looking up the properties of the soil. I've already talked about soil properties and how soils behave, but once you use the soil pyramid, just like this one here, boop, then we can start looking up the properties of these soils and how they behave for sure, so that we know what recommendations to make and what to not do, so as we protect our habitat and we don't make any big mistakes.